welcome back to my channel. My name is Prachi Sharma, and in today's session we are working on some important questions of ammonia. So you may see in this today's session, you'll see a lot of questions which will have similar answers or similar questions in different formats. The reason I have included all of those questions is because I want you to understand that from a similar topic you can get the questions in different formats. Sometimes for lab preparation you may get a 4 marker, sometimes for a lab preparation you may just get a 1 marker. So depending on that, I have included all the questions so you get a better idea that the concepts you are working on can be asked in multiple formats. So without wasting any time, let's get started. Alright students, so let's get started with today's session. As the other important question videos are, it's gonna be in the similar pattern. That means I'm not gonna write whole answers. I'm just gonna go ahead and it will be more like a discussion. We'll be discussing the answers. If you have any doubts or concerns, you can definitely reach out to me in the comments box or the Telegram channel, or you can also write me an email on psclassesicsc@gmail.com. So let's get started with the first question. So the first question says, the following questions are based on the preparation of ammonia gas in the laboratory. The first question, explain why ammonium nitrate is not used in the preparation of ammonia. So the reason is that ammonium nitrate is explosive in nature, so you cannot use that in the preparation of ammonia. The second is, name the compound normally used as a drying agent in this process. So in this process, quicklime is used as a drying agent. Moving to the third question, how is ammonia gas collected? So ammonia gas is collected by downward displacement of air. Let's move on to the fourth question. Explain why it is not collected over water. The reason is that it is highly, or you can say it is extremely soluble in water. Therefore, we cannot collect it over water. Let's move ahead to the next question. The diagram shows below an experiment setup for the lab preparation of a pungent smelling gas. The gas is alkaline in nature. So now you understand here that it is also based upon the lab preparation of ammonia, but in this particular question they never said they're talking about ammonia. They just gave you a setup and they said that a pungent smelling gas is a lab preparation of that gas, and that particular gas is alkaline in nature. So one thing that you can remember is that for your syllabus, the only alkaline gas you're going to talk about is ammonia. So that's the answer for it. So the first question is asking, name the gas collected in the jar. So the gas collected in the jar is ammonia. The second thing that is important for you to notice in this particular diagram is that even if you're not sure about what the process is, try and understand that from the collection jar. What kind of collection jar they are using, how is the collection jar set up, that can also help you understand which gas that is, because it can happen that during the exam you do not remember which alkaline gas was it, but you may remember that okay, it was how it was collected, what was the collection type. So that can also help you identify the type of gas. Let's move on to the next question. The next question says that write a balanced chemical equation for the above preparation. So let me quickly write that here. So that would be 2 NH4Cl plus COH whole twice, and you heat that, you get CaCl2 plus water plus ammonia, and that's it. Let's move to the next question. How is the gas being collected? It is collected by downward displacement of air. Then the next question is, name the drying agent used. So that is quicklime or calcium oxide. Then the next question is, how will you find that the jar is full of gas? So what you can do is you can use the litmus paper test. That means you bring a moist litmus paper on the near the top end of the jar, and that can help you in the identification. The second is I think the litmus test should work the best. The other one could be any test of ammonia that you know. For example, the glass rod dipped in HCl gas, you can bring it near, you'll see white dense fumes. So any of that would work. So the best case scenario would be to use a red litmus paper which will turn blue because it's alkaline gas. Then moving on to the third question. So the third question says, from the list given below, select the words or word required to correctly complete the blanks. First to fifth in the following passage. Always read the entire question in the paper, because this particular question is giving extra instructions. That is, words chosen from the list are to be used only once. Write only the answers. Do not copy the passage. So these are important. This is important information about this particular question. So to avoid any silly mistakes from your end, it is important that you read the entire thing properly and then attempt the questions. So let's look at the words. The words that I have is reddish brown, ammonium, nitrogen dioxide, hydroxyl, dirty green, ammonia, acidic and alkaline. So let's start with the passage. So the passage says that nitrogen and hydrogen combine in the presence of a catalyst to give ammonia. Nitrogen and hydrogen is being combined, so it will give me ammonia gas. When the above mentioned gas is passed through water, it forms a solution which will be alkaline. When you mix water with ammonia gas, you get an alkaline solution. Then the next is alkaline in nature and solution contains dash. So what kind of ions will it contain? It will contain ammonium ions. So ammonium ions. Then the next part is dash ions. Ammonium ions are hydroxyl because it's alkaline in nature. So along with ammonium ions, you will also contain hydroxyl ions. So let's quickly tick out what all you have used. So you have used ammonium, you have used ammonia, you have used not acidic, we have used alkaline. So we have used alkaline. So this we have also used hydroxyl. So we have used these. Now let's move ahead. Now the next part says that the above solution when added to iron 2 sulfate solution gives a dash colored PPT of iron 2 hydroxide. So if you remember this from, either you would have learned this from analytical or you would learn this in this chapter. So wherever works best for you, you need to remember the color of precipitates. So in this particular case, you have iron 2. So that is your dirty green. So dirty green PPT. Let's move on to question number 4. Now this is also based upon preparation. So let's say, okay, this is about reaction of ammonium chloride. So write the equation for the following reaction. Ammonium chloride is heated with sodium hydroxide. So you just have to write the equation. So NH4Cl, ammonium chloride reacting with sodium hydroxide NaOH will give you NaCl plus ammonia plus water, and then you can just check the balancing of it, and that's it. Let's move on to the next question. The question says that the questions below are related to the manufacture of ammonia. The first is name the process. So what is the name of the process? That is Haber's process. So let me just write that here. Name the process. So that is Haber's process. So HABERS, Haber's process. Then the next is, in what ratio must the reactants be taken? So they are always taken in the ratio of 1:3. So you have NH3. So 1 ratio of nitrogen and 3 ratio of hydrogen. So that is your ratio of the reactants. So always mention what is the ratio, 1:3 and 1:3 of what? So nitrogen is to hydrogen is 1:3. The next is name the catalyst used. So in this case, you use finely divided iron as a catalyst. Then the next question is, give the equation for the manufacture of ammonia. So you just have to give in the equation. So that would be nitrogen plus hydrogen in the presence of finely divided iron or molybdenum, and the temperature 400 to 500 degrees Celsius. And this will give you twice of ammonia, like 2 of ammonia molecules. Let's move ahead to the next question. Ammonia can act as a reducing agent. Write a relevant equation for such a reaction. So you can use any of that if you remember the reducing agent equation from this particular chapter. So that is with copper oxide. So CuO plus ammonia. CuO plus ammonia, that will give you copper plus water plus nitrogen gas, and then you can balance it out. So this is what your reducing agent equation will be. Let's move to question number 6. It says select the correct answer from the choices A, B, C and D which are given. Ammonia can be obtained by adding water to what? So this is when you have nitrates, metal nitrites that you use for the preparation of ammonia gas. That is the second preparation method of ammonia, the one that we do not prefer because it is expensive. So this is the one that we're talking about. So if we take a look at that, so in this case, if you look at all the options, your option would be magnesium nitride. So that will be option number C. Let's move ahead to the question number 7. Identify the following substance. An alkaline gas A which gives dense white fumes with hydrogen chloride. So the only reason I mentioned this question is because when you know that we're talking about the chapter ammonia, it is easier for you to quickly understand that. But you may get this answer in the exam. So in that case, you're doing all of the questions together. So it's important for you to have the ability to recall that the alkaline gas which gives dense white fumes with hydrogen chloride is ammonia. So let's quickly move on to question number 8. It says copy and complete the following table relating to important industrial process. Output refers to the product of the process, not the intermediate steps. So let's start with this. So it says name the process. So that's Haber's process. Inputs would be hydrogen plus nitrogen. What is the catalyst? That is iron, finely divided iron. It's not clearly visible on white, so I'm just going to write here. So it's finely divided iron. Then you need to give in the equation. So that would be nitrogen plus hydrogen, which will give you 2 molecules of ammonia. What is your output? Output is ammonia. Okay, let's move ahead to the next question. So the next question is also based on a similar pattern, and both of them were part of board examinations in different years. So let's start with this one. So this one is copy and complete the following table relating to the industrial process. So in this also you have the industrial process. So let's quickly look at that. They are saying it's Haber's process. You need to mention the temperature. So temperature is about 450 to 500 degrees Celsius. Catalyst is finely divided iron. Equation of the catalyzed reaction. So that will be nitrogen plus thrice of hydrogen, which will give you twice of ammonia. So that's it. Let's move ahead to the question number 10. Name the gas evolved when the following mixtures are heated. So when you have calcium hydroxide combining with ammonium chloride, you end up getting ammonia gas. That's the preparation of ammonia. So you end up getting ammonia. And when you have decomposition of ammonium nitrite, so nitrite, ITE, make sure that you read it very carefully. It's nitrogen gas. So nitrogen gas. Let's move on to the next question. During the lab preparation, how is ammonia dried and collected? So again, see, the lab preparation of ammonia can show up in different methods. For this particular question, you're just supposed to tell the collection and how is it dried. So it is dried by quicklime and by the use of quicklime. And how is it collected? It is collected by downward displacement of air. So let's quickly move on to the next question. Question number 12. Write equations for the lab preparation of ammonia from ammonium chloride. So of course when you're doing this, so let me just write the equation for you. So ammonium chloride, so NH4Cl plus NaOH, you heat that, you end up getting NaCl plus ammonia plus water. So that's it. Let's move to the next one. Some word or words are missing in the following statement. You are required to rewrite the statements in the correct form using the appropriate words. Now this question, I also saw this in a couple of pre-board question papers. So make sure that you pay attention on this one. It says magnesium nitride reacts with water to liberate ammonia. And a couple of students asked me when they were discussing their pre-board question paper with me that, ma'am, this looks perfectly fine. What can we add here? So there's an important minute detail that you have to add, that is warm water or hot water. So warm water will liberate ammonia, not just the regular water. So let's move on to the next question. Write a fully balanced equation for the following case. Magnesium nitride is heated with warm water. So see, you have that. So Mg3N2 plus water, and then you are heating it. This will give you MgOH whole twice plus twice of ammonia, and that's it. Now the next is write equations for the following reactions: aluminium nitride and water. This is an important one. So aluminium nitride is Al(N) plus water will give you aluminium hydroxide plus ammonia. Let's move to the next question. You enter a lab after a class has completed the fountain experiment. How will you be able to tell whether the gas used in the experiment was hydrogen chloride or ammonia? So of course there's a very huge difference between the two. If it was hydrogen chloride, that is an acidic gas. If it was ammonia, it's an alkaline gas. And fountain experiment shows a color. So if the color is turning from red to blue, it's ammonia, and if it is turning from blue to red, it is hydrogen chloride. Let's move ahead to the next one. Copy and complete the following experiment. Okay, one important part about the previous question is that they have said when you enter the lab, a class has completed the fountain experiment. So when they say it is completed, so you need to just check the color of the trough. So you can just mention that if the trough is let's say red in color, that means the testing was done for ammonia, because you would turn red to blue. And if the trough was containing blue colored solution, that means if you were testing hydrogen chloride gas. So because they are not saying that you are doing the experiment, the question is saying the experiment was already done when you entered the class. So make sure that you mention the color of the trough. Okay, let's move to the next question. Copy and complete the following equations. So you have magnesium nitride plus water. We have already done this equation today. Ammonia plus copper oxide, we have done this. We have not done the chlorine one. So let's quickly do the chlorine one only. So chlorine and oxygen, we have not done both of them. So for chlorine, you will get ammonium chloride. So that would be NH4Cl plus nitrogen gas. And for oxygen, you will get ammonium chloride, NH4. You'll get ammonia. Let's see. You'll get NO and water. So you'll get NO plus water. That's it. Let's move to the next question. How would you obtain compound? How would you obtain compound magnesium nitride? So how do you obtain that? You obtain by burning magnesium ribbon in a jar of nitrogen. So when you burn magnesium in a jar of nitrogen, you get magnesium nitride. Which property of ammonia is illustrated in the reaction above? So if you look at the reaction in a second part, so that was CuO. So if you remember, we did this as an example in the reducing agent characteristic of ammonia. So the answer for this particular case would be the property, that is reducing property of ammonia, is being discussed or is being shown in this particular reaction. So reducing agent. The next is what is the name of important industrial process that starts with reaction A fourth part? So reaction A fourth part. So they are talking about, okay, so they, in this one you have to pay attention that they are not talking about the manufacturing of ammonia. The question is saying what is the name of the important industrial process that starts with the reaction above? So this particular reaction, if you take a look at this particular reaction is the first step in the manufacturing of nitric acid, and the important process they are talking about is Ostwald process. So that is the answer for that. They are asking name the important industrial process that start with this reaction above. So that is Ostwald process, that is used for the manufacture of nitric acid. The next question is, during the lab preparation, how is ammonia dried and collected? So now, by now you would have understood how important this particular question is. So ammonia gas is dried over quicklime and it is collected by downward displacement of air. Let's move on to the next question, students. Explain why ammonia gas is evolved when water is added to the product formed when magnesium is burned in the air. So now, as if you take reference from one of the questions above, you would understand that when you burn magnesium in air, you end up getting magnesium nitride. So when magnesium is burned in air, it forms magnesium nitride, and if you use that and react it with water, you end up getting ammonia. So let's see what the question wants from us. So explain why ammonia gas is evolved when water is added to the product formed from magnesium is burnt in the air. Okay, let's quickly look at the equation here. So what they're saying is that they're saying magnesium is burnt in air. So when it is burnt in air or in a jar containing nitrogen, so what would happen in that case is magnesium will burn with nitrogen, whether you're burning it in air or burning in a jar of nitrogen. So you end up combining with nitrogen and that gives you magnesium nitride. So Mg3N2. Then this Mg3N2 combines with water, warm water. So Mg3N2 combines with water. This ends up giving you magnesium hydroxide. So MgOH whole twice plus ammonia gas. So this is how you would explain that this is what's happening here. Alright students, let's move ahead to question number 19th. So as you can see that on the screen very clearly, the question says, though ammonium nitride readily gives nitrogen on heating, a mixture of ammonium chloride and sodium nitride in water is heated to prepare nitrogen in the lab. So the reason is that ammonium nitride cannot be stored at room temperature, so therefore it is difficult. So therefore nitrogen is obtained by heating ammonium chloride and sodium nitride. Let's move on to the next question. Ammonia cannot be collected over water. Of course, the reason is it is highly or extremely soluble in water. Let's move ahead to the next question. Question number 20th. Identify the substance Q based on the information given. The white crystalline solid Q is soluble in water. It liberates a pungent smelling gas when heated with sodium hydroxide solution. So the answer is ammonium chloride. This is also given in the book itself, and you should be able to find it. If you're not, you can ask me that in the comment box. I'll let you know. For now, let me just tell you the answer. The answer is ammonium chloride. And this was also taught in the one-shot video of ammonia. If you have doubts, you can check that video out. So my dear students, this is where we conclude today's session. I hope this session was helpful for you. I know you're putting in a lot of efforts to get a better score in your board examinations. I'm thinking about making a video for those students who find learning equations very difficult, and I'm trying to make them understand that they can still score good marks even if they're not putting all their efforts on the equations. So if that is something you are interested in and you would like me to cover, please make sure that you let me know that in the comment box below, and I'll make sure that I put out a video on that discussing on what your plan should be if you're not super good at learning equations, how you should plan and how you should target your examination to get the best marks as per your capabilities. So let me know if that is something you would like me to cover. So thank you so much students. We'll catch up in the next session. I hope you have a wonderful day.